Okay, so this says that 100 grams of carbon-14 decays until only 25 grams of carbon is left after 11,460 years. What is the half-life? Well, it says that original amount will be 100 grams. It decays until the amount left is 25, which is N. And then we're doing it over the time period of 11,460 years. And we're solving for the half-life. It says, what is the half-life of carbon-14? Well, let's set up my equation here. I have 25 is equal to 100 times 0.5 raised to the 11,460 divided by capital T. Now, I'm going to divide both sides by 100. If you watch my other video, you'll know why I'm doing this, just to simplify this side so I can get the logarithm of both sides. So then I have 25 divided by 100, which would be 1/4. Of course, which is what? 0.25, which is equal to 0.5 raised to 11,460 divided by, let me write that readings, 11,460 divided by capital T. Now, I can actually get what's called the logarithm of both sides, which will, the logarithm has a special property that allows me to bring an exponent in and make it as a, rewrite it as a base. Now, remember, this here, sorry, I can't. We have to remember this here is an exponent. This is an exponent. So I get the log of 0.25 is equal to the log of 0.5 raised to the 11,460, all divided by T. Now, by using that special property there called the product property, power product property, I'm sorry, I'll be able to rewrite it like this. Log of 0.25 is equal to 11,460 divided by T log of 0.5, because that property says that I can take this exponent and I can bring it down as a base. Okay, now to simplify, to get T, we can multiply both sides by T. These T's would cancel. I'm sorry, they would cancel. I'll be left with T times the logarithm of 0.25 is equal to 11,460 times the log of 0.5. Now I want to get big T by itself, so I need to divide by log of 0.25 because that's what's keeping big T from being alone. So divide both sides by log of 0.25. That they would cancel. I'll be left with T is equal to 11,460 times the logarithm of 0.5. Let me write that 0.5 in there. 0.5, which would give me a certain number there. Give me 1 second here. 11,460 times the log of 0.5. And then that will give me a number, and then I'm going to divide that by log of 0.25. And I will come up with 5,730 years. So that is my half-life of carbon-14. That is the half-life of carbon-14, given these given these requirements above. I can't think of the other word to use, but yeah. So basically, our answer for this problem would be the half-life of 5,730 years.